Okay, when we did our making sense of density lab, we found the density of pennies that were manufactured after 1983. And these pennies are not made of pure copper. They have a large component of zinc in them. And so what we wanted to try to do is figure out, if we could figure out if we knew the densities of both zinc and copper, and we knew the density of the overall penny, then could we work backwards and figure out what the percent of the penny was zinc and what percent was copper. And this involves two unknowns and is kind of some tricky algebra. So before we do that, let's just kind of look at the forward method and think about your grade in a class. Most of you know that some of your grades, you might have like, for instance, you might have like an A in the class. We'll have like a 95%. And on your final exam, let's say that you get a 72. Well, these are certain percentages of your grade. So the 95, it might be 70% of your grade, and the 72 might be then 30% of your grade. The percentages should add up to 100, of course. So there's only two parts of your grade. And a lot of times students ask the question, how do you figure out what your overall grade is? So the math on this is fairly straightforward. You just take your grade in your class, which is a 95, and you take it times 70%. Now, if you know how to take it times percent of something, you take it actually not times 70, but times 0.70. So 70% of 95 plus, and then you just take 30% of your other grade, 72 times 0.30, and you just put that in your calculator. And if you do that, you'll see that you're going to get an 88.1% as your grade. You'll notice that 70% of your grade was the 95, so the grade that you get is a lot closer to 95 than it is to 72. If these were both 50% each, then it'd be easy. You could just take an average. You could add them both together and divide by 2, and you'd be exactly in the middle. But this is called a weighted average, a percent average, and so it's a little harder to do. So 70% of 95 plus 30% of 72 gives you your overall grade. So that's how we could work that forward. Now this applies then to density. If we know, for example, that the density of some element, we'll say, is 6.12 grams per milliliter, and the density of another element is 8.73 grams per milliliter. And let's say that there's a coin that's made of these two elements, whatever these elements are. I just made these densities up. But let's say that the coin is 80% this element and 20% this element. What would be the overall density of the coin? Well, it should be a lot closer to 6.12. It should be between 6.12 and 8.73. It has to be within this range. But you'd expect it to be a lot closer to 6.12 than 8.73 because it's 80%. It's composed of 80% this element. So you'd expect it to be a lot closer. So if I want to do that, I can do it just like I did my grade. I would take 6.12, I'd take 80% of that density, plus 20% of the second density. And if I did that in the calculator, I get a density of the overall penny to be 6.64 grams per milliliter, which is a lot closer to 6.12 than it is 8.73, which is what you would expect. The 80% is going to skew it a lot more towards that density than it is this other one. Okay. So that's pretty straightforward. That works out pretty well. That brings us to the challenging problem that, of course, we had, and that is that we figured out what the density was of the post-1982 pennies, and it was 7.20 grams per milliliter, or it was something for you, whatever you got on the slope of your graph for that. But I'm just going to use it. I'm going to pretend we got 7.20. Well, we know that the penny is made of zinc and it's made of copper. The density of zinc is 7.13. The density of copper is 8.93. And what we're trying to do here is do the reverse problem. We're trying to figure out what percent of this penny is zinc and what percent is copper if the overall density of the penny was 7.20. Now you can look at this and kind of make some guesses. 7.20 is way closer to 7.13 than it is 8.93. So the percentage of zinc is going to be pretty high. It's almost all zinc. So I need to figure out, X percent and Y percent. What percentages of the coin are each of these? And that's two unknowns. So that makes it a little tricky. So we actually need to solve for two unknowns. You need two equations. Well, we know that the penny is only made of two things. So X plus Y should be 100%. Right? X plus Y should be 100%. Now we're going to solve for X and Y in decimal form. Remember, when we took the percentage of something, you actually put it in decimal form. So instead of X plus Y equaling 100, we're going to say X plus Y equals 1, because if these were in decimal forms, then they would equal 1. The other equation that I would need is the one we've been practicing with so far. If I wanted to figure out what the overall density of the penny is, I'd take 7.13 times X percent plus 8.93 times Y percent, and that would give me my overall density of the penny, which is normally what you're trying to figure out. But in this case, we actually know it. So we know this side of the equation, but we don't know our X's and Y's. So how can I figure them out? Well, if I have two equations, I can rearrange one equation and then sub that into the other equation. So I could say that X plus Y equals 1, and that means Y would equal 1 minus X. And then I can take this Y and plug it in right there for that Y there. So I would end up with 7.13 X plus 8.93 times a quantity, 1 minus X, equals 7.20. Okay? And so now I have nothing but X's in here, so I can just have to algebraically solve for this. Hopefully we can all do that. 7.13X plus, I'm going to distribute this, 8.93 times 1. Whoops. 8.93 times 1 is 8.93. And then 8.93 times a minus X is a minus 8.93X equals 7.20. Okay, so I'm going to combine like terms. So I'm going to take 7.13X minus 8.93X, and that would be minus 1.80, because I would have to go to the hundreds place because they both went to the hundreds place. X equals, and I'll combine the other terms, take 8.93 over to this other side, and I would get minus 1.73. And then X would equal negative 1.73 divided by negative 1.80. And if you put that in your calculator, you'll get equals 0.961. Of course, we want to, that's a percentage in decimal form, so take it times 100, and we see that this penny is 96.1% zinc. 96.1% zinc. And so it's about 3.9% copper. And that's why, because copper is very expensive, so they don't want to use very much of it. So this is how we can solve a percent composition problem. You'll have to do several of these problems on every competency that we do on the dimensional analysis kind of stuff. And so this is going to be part of that. And so you need to know how to solve for X and Y. If I give you two densities and I give you an overall density of a coin, you should be able to figure out what percent of it is what. And that's kind of a little tricky math, but hopefully you can figure that out.